brought down my CP22E antenna, which had developed an angle between the two collinear 5 by 8 lambda elements beyond the facing coil. Main purpose was to see if I can get access to VU2EDJ VHF repeater, which had been serviced in detail by the local team as reported by VU3UQI on X, with a lot of nice pictures. Details of the VU2EDJ repeater repair, as mentioned, is worth reading for anyone using the repeater. Quite a lot of effort has gone into the repair, leave alone the expense of components. So I was keen to regain access to VU2EDJ repeater located at 41.3 km from here. Access to VU2EDJ repeater will greatly improve my range of VHF communication to the north of my region. After lowering the CP22E antenna, the angle between the two collinear elements was corrected manually. The antenna was suspended on a nylon rope from a pole so that I could work on it without sitting or bending down. The mounting CPVC pipe was removed by unscrewing the clamps at the base. This is the replacement mast, a 3-element adapter used for wall painting, used to attach roller brushes for painting higher up in the wall, whisked from the home store. The segments are telescopic with latches which can be locked in position. Hence, if I want to reduce the height of the antenna with the onset of thunderstorm season, height can be reduced significantly by opening the latches and sliding back the telescopic elements. I have been using a similar mast for my dual band VHF Moxon-Yagi meant for low Earth orbit satellite operations and found it very convenient to use. It is sturdier than the previous mast, which was 1-inch diameter CPVC pipe, yet not as strong as a galvanized iron pipe. Advantage is that I can handle this alone while I need the help of another person if I want to install the GI mast, which is also longer and heavier. Carefully fix the base of my CP22E antenna to the telescopic mast and tighten the screws. Extreme care is needed because of the radials, which can cause personal injury inadvertently, as I could not get hold of suitable end caps for them. Tape the joints for whatever protection it might give from rainwater in the rainy season. Previously used tapes had all worn out and were removed prior to that. Screw on the earth wire attached to the base of the antenna was cleaned and tightened once again. Earth wire had been grounded earlier using a 4-foot copper-clad iron earth rod driven down in the garden below. As it was between the plants, it would get automatically watered daily as well, which would improve the earth conductivity. Mounted the mast with antenna on the first floor parapet and fixed it well at several sites. It is well supported by the parapet fence, rainwater gutter and end of the lower part of the sloping roof, and I hope that this position will be reasonably stable against wind loading. Now the CP22E antenna is about 7 meters from the ground, but still below the level of my water tank, a landmark I use to compare the height of my antennas. Couple of turns of HLF 200 feed line have been fixed as a possible common mode choke on the mast. I do hope that it will reduce the common mode current on the outer aspect of the coaxial shield and reduce the entry of radio frequency energy into the shack. Grounding of the base of the antenna is also useful for this and possibly for minor lightning protection, I presume. I have used 10 square millimeter insulated copper wire for the ground connection, which was the thickest I could source from the local shop dealing with electrical wiring components. Went inside and checked the SWR using my cross needle meter. I am using 10 meter of HLF 200 cable from the antenna to the SWR meter. 1 meter HLF 200 patch cable connects the SWR meter to the SO239 on the radio. Tested on low power in my IC2730A radio and found the SWR to be below 1.1, suggesting a good tuning of the commercial antenna, which has not worsened over the past nearly 2 years of use. This was my workhorse antenna for a good number of LEO satellite contacts when I started LEO satellite operations nearly 1.5 years back. I have worked both VU satellites and UV satellites with this antenna. It had an SWR of around 2.25 on UHF amateur radio band, working as third harmonic of the VHF amateur radio band. For those not familiar with satellites, they have cross-band repeaters. VU satellites have uplink on VHF and downlink on UHF, while the UV satellites have the other way around. International Space Station has a VU transponder and it is the easiest to work. You talk on 145.990 MHz and hear back on 437.800 MHz. Finally, I checked access to local VHF repeaters. VU2CSR repeater at 3.8 km had full segment reception in my IC2730 radio as usual. VU2MJJ repeater has been down for the past few days and I could not get access. Surprise came on VU2EDJ repeater at 41.3 km. Earlier, I was getting VU2EDJ repeater with just 2 segments of signal strength on the meter in my radio. This time, the signal strength meter showed solid 8 segments of display. That is really wonderful, and I am sure that servicing of VU2EDJ detailed by VU3UQI on X is really effective. Congratulations to the team at VU2EDJ, including VU2SJP and everyone who has contributed for the wonderful work, and to N3SDO help mentioned by VU3UQI. Hope to have many contacts using VU2EDJ repeater in future. A link to the pictures of repair posted on X is included in the description of the video.